board of director member of NeXT, one of the people that really urged us to start this company in the first place, and he's president of Georgia Institute of Technology.
There's a mic right there for you.
I was supposed to have one on here, actually. And does this one work?
It's not on.
Oh, I didn't turn it on. How's that? Thank you. Technology, can't live with it. Can't live without it. Everybody, I think, knows Ross Perot, member of our board of directors. Dr. Bud Tribble. Computer. And I think that's about it. So why don't you guys come on over here?
That one isn't working. It's not happening, so.
We'll deep six this. Thank you. Okay. So, what should we do? Yes.
Is the color in the room? Color in the room?
Oh, excuse me. Color. Why don't we explain about color? We had a... What is that strange noise? Oh. We had a fundamental decision to make about color. And that was that we decided that megapixel was more important than anything else. In other words, once you put out a small screen, you've got to live with the results forever during the entire computer architecture's life. So we knew if we came out with a small color screen, baby color we call it, that we would be forced to live with software needing to run on that small screen forever. And all the application developers would be constrained. You would never see programs like Dr. Richard Crandall's Stat Lab today because they wouldn't fit on the small baby color screen. And to do megapixel color today would have doubled the price of the machine. So what we decided to do was do megapixel black and white at a level of clarity and definition that I don't think the industry's ever seen before. And you will see some very fine stuff from us in color next year. The display here is not only very high definition monochrome, but it's also 2 bits per pixel, so we get some grayscale involved. And I think because our unit is expandable, you'll see some stuff from us next year that you can add on to it if you want to go into new dimensions. I think we'll be talking about a lot of stuff next year in that regard. Do we expect software developers? I shall. Do we expect software developers to distribute their software on optical disc cartridges? The answer is yes. The question is, if the cartridges cost $50, is that going to mean that software costs more? For packages that cost in the multi-hundreds of dollars, of course not. One thing we also need to remember is that the most expensive part of any software package today is often its documentation. Because of the digital library capabilities of the machine, we can put the documentation on the disk itself, thereby saving all the production costs. And in addition to that, since we can make, as a software developer, can make the disk a day before they ship it to a customer, unlike manuals, which they have to print 2 months in advance, they cannot have inventory of products that aren't selling and things like that. So there's some tremendous advantages to actually using that technology. We're selling the machine to the higher education market. We started off saying that that was the market we wanted to serve, and it's really true. And we're going to be selling the machine to higher education for $6,500 as we outlined in the presentation today. It will be available to people who work and study at higher institutions of higher education. Currently just in the United States. Turns out that the higher education market is very large. And it's going to probably take us a while before we can even begin to meet the demand of higher education in America. So that's what's going to come first for us. And after we get to a point where we can do that, then we can start thinking about other things. Yes, NeXT is building a direct sales force, and with the help of higher education to guide us and steer us right. And we're really happy with how that's coming. We'll be selling directly to higher education. I think we're going to be selling to higher education. Real simple focus. More companies tend to die of indigestion than starvation. And so we're going to stay really focused. But were most of you at the presentation today? I assume all of you were. What did you think all in all? Did you like it? Yeah? Yeah. Question was, are we making any money when we sell one at $6,500? Or are we losing money on everyone and making it up in volume? No, we are making money. We like to employ engineers and come up with new breakthroughs, and to do that, you have to make a profit, and we are. Excuse me. What is our optical disc technology? Yes, we are using magneto-optic technology. Most of you know how that works. It's really great. Well, the way it works is on a disk drive like a Winchester, you can the whole point is to make the magnetic spot size very small so you can fit a lot of bits on the surface. And to do that, you have to put the head closer and closer to the media. And it's been described as a 747 flying at 500 miles an hour, 6 inches off the ground. And that's what a head of a Winchester looks like. So you can understand what a Winchester crash is like when you lose all your data. The optical disc is very different. What it does is it uses a beam of light to heat up a material to its Curie point, in which case it changes its magnetic orientation. And it works very, very well. The only thing that ever gets close to that media is a beam of light. And we're finding that the optical media is far more reliable than the low-end Winchesters that you find in most computers. How fast? The optical disc actually spins at, I believe, 3,000 RPMs, giving us a transfer rate of about a megabyte per second. Access time on the disk, the usable access time is, I think, around 60 to 70 milliseconds. And I can... sorry, what's that? Oh, it's really easy. You pop it out, you take it to the library where there's a 2-drive machine, and you copy it. Or you use the network and copy it on your friends in the next office. Because these things are removable, you don't have the same problems you have with Winchesters. You can pop your whole world out and throw it in your backpack. Sorry, I believe IBM has plans to bring this out on their RISC-based platforms and on their Intel-based platforms. I think it's going to be pretty exciting. I think the 386 platforms as well, but I think probably it's best to ask them. They decided this probably should be next product introduction, but so I think there's some press materials. The question is, will we be incorporating object-oriented kits to help build animations, and how far can we go? We already have. That's part of what's in the system. And you'll be seeing some things, I think, over the next 6 months roll out that are pretty exciting. We currently don't have NTSC video output on the machine, although that's entirely possible. We will be selling to universities who will, in turn, be reselling to faculty, students, and stuff. And the prices they charge for those things are up to them. Do we have any contracts with any universities yet? Yes, we do. Several. I have absolutely no idea. Some people have said a lot about this computer, haven't they? And some are right and some are wrong. Those are the kinds of things we just can't discuss publicly. We can make a lot, but probably not enough. Daniel Garrick. European universities, as soon as we can come even close to supplying the demand of higher education in America, we would love to have this be a worldwide standard, and we intend to do that. But first, we've got to focus on higher education in America. I don't know. It's a pretty big market. We could, but we'd rather not. Question was asked about Sybase. One of the great things about this computer is that it's not just a hot hunk of iron. It's a very, very sophisticated software system. And we realized that the more we put in this box, the higher level that application software developers start at, which means the neater programs they can write in the same amount of time, or they can write programs of current complexity in far less time. And realizing that databases are very important, we were able to reach an agreement with Sybase to bundle their entire SQL server and database libraries in this thing, so that people are going to be able to take advantage of what we feel is the best relational database technology around in every computer they buy. And what that means is that when all these people write all these applications without ever talking to each other, they can exchange data because they'll all be in the same database. Will application programmers have access to... You mean how will they duplicate their disks? Oh yes, they can just get a system and duplicate them themselves. Yeah. Our relationship with Lotus is that we've been working with Lotus for some time now to put their software on this platform, and I think you'll see some pretty neat things. Unfortunately, we can't announce products for our application software developers. They have to. Who makes our disk drive? We were really lucky when we started NeXT in that we got calls from the presidents of Sony, Motorola, Canon, and others. And they said, hey, when you guys were in your former lifetime, you used to romp through our technology laboratories. And you used to spot technologies and help us form them into marketable products. And we really like that because both of us won. So we'd like you to keep doing that. And we'd like you to keep doing that because A, maybe you'll be the next big computer company, and B, because you're the cheapest R&D we could ever do. So we had access to, I think, probably more of the in-depth technical research going on at some of these companies than most other people have the good fortune to have. And we spotted something in the laboratories of Canon. And what it was an early prototype of this optical technology. Now, Canon, as you know, is very, very good at coating materials like lenses, like laser printer toner cartridges, like optical cartridges. And they came up with the best media in the world. And we worked together with Canon for the last 2.5 years. And it turns out on our board, I don't think I have one right here, do I? No. On our board, those two big mainframe on a chip chips, it turns out that 3/4 of one of them is an optical disk drive controller on a chip. It started off with 3 boards this big in the laboratory, and we shrunk it down to 3/4 of one of those chips. That's all proprietary to NeXT, and it's what's enabled us to get the performance up and bring the cost down. The other thing is, it turns out hooking one of these up to a software system is really difficult. And we put in a tremendous amount of work to make this real in a computer system as the main primary storage device. So we've done this in partnership with Canon, and it's turned out really fantastic. Of network computers can look like one large file system. And secondly, we've put front ends on Unix mail, as you saw today during the demonstration, so that mere mortals can use these types of things. But the base underlying technology, we inherited a lot of the minute we decided to go with Unix. The other thing that I might mention is we have, of course, full, very high-speed Ethernet built into every computer. And the thing, of course, supports the TCP/IP protocols, which are the standards of higher education. First question is, are we sending any of this to OSF? We have no plans to do that at the present time. Secondly, why didn't we use a RISC processor? It turns out that the 68030 in this box running at 25 megahertz is running a real solid 5 MIPS. That's about 7 MIPS from some other companies, but a real solid 5 MIPS. And that is approximately half the performance that you get out of a $40,000 to $50,000 RISC-based workstation. So what our game plan is real simple. We may not always build the fastest computer. You may be able to go pay $50,000 and buy one that's faster. But given a certain amount of time later, we want to bring the same thing on a desktop for this class of price. And that's what we're planning on doing. I think 5 MIPS puts it about 10 times over where we were with the Macintosh the day it was introduced. Uh-huh. It is a Canon engine inside the printer. Yes, it is, actually. We worked with Canon on this engine as well, and what we did was we took a standard SX engine and we made it a lot smaller. So it uses the same exact cartridge as all the other popular laser printers in the industry, but it's about 60% of the size. It's got a totally straight paper path, which means it's a lot less likely to jam than these curvy things. And it has to plug directly into the wall, but it connects to the computer with one 3-meter cable. There are no switches and no lights on this printer. It is turned off and on totally by the computer. When you get a paper jam or you're out of paper, you don't get some little LEDs telling you. The big screen tells you. Matter of fact, it can even tell you in a voice message. You can say you're out of paper. So, sorry. We do our imaging inside the workstation. If you look at a $7,000 laser writer, you've got a 68020 processor, and you've got about 2 megabytes of RAM. We've got a 68030 and 8 megabytes of RAM and a disk to hold all the fonts. So we image like crazy. And we turn on one of our DMA channels and blast the bits out of over our cable. We have a custom VLSI chip in here that inherits those bits and controls the entire printer in one chip. The printer is designed to work with a NeXT computer system only. The thing that software developers want is when they develop an application for one computer, they want to, in a reasonably short amount of time, with a reasonably small amount of investment, be able to generate versions of that application so that they can sell on other computers. They don't need the same disk to work in these various computers, but within a week or two or a small number of weeks worth of work, if they can take the result of a 3-year development effort and all of a sudden in 3 weeks have a version for a new computer by simply recompiling it to run on top of the next step running on another hardware platform, this is a revolution. And that's what we're trying to achieve. As an example, if somebody writes a program for this next computer here, as a perfect example is Frame. We looked out there and we asked who's got the best technical publication system out there running on workstations, and our answer was Frame. And we started working with Frame. Frame was the first application software developer I believe we started to work with. We've been working with them for a long time. Their software's up. I was going to try to demonstrate it today, but we were running out of time. And it's quite remarkable. And they will be able to take this when they're done and theoretically recompile it for next step running on the IBM platforms and be able to generate a product for the IBM platforms in a fraction of the time it took them to write the original product for this. Oh, I mean, this is not a problem, yeah. Excuse me, what was that? Do we allow a bridge? No, this machine doesn't run Macintosh software, just as the Macintosh didn't run Apple II software. Sorry, what's that? Sure. It actually happened. There was a little snippet in Forbes magazine. I don't know if you saw it. It actually started when both John Akers and I happened to be attending the 70th birthday party of Katharine Graham in Washington. We were introduced, and we got to talking, and he invited us out for lunch in Armonk. And this was an interesting experience. What's really turned out to be great is that we're focusing on higher education. And IBM has a much broader market than we are focusing on ourselves. And they also have the ability to incentivize every single software developer to write for the mainstream platforms that they adopt. So in forming this partnership with IBM, we've pretty much guaranteed that software is going to be developed for the next step platform at a previously impossible pace. Yeah, I think the team that built this computer works at NeXT, and the team that did Next Step works at NeXT. And there are some things about this computer, of course, which we haven't licensed to anybody. Obviously, not just the hardware, but the entire digital libraries. The digital library stuff has not been licensed to anybody, nor has any of the sound and music, nor have any of the bundled application software. So I think that taken together, we have a pretty strong competitive offering. But most importantly, the world has now got two companies who are going to both be working like crazy to make the best next step platforms in the world. And everybody wins when that happens. So, stereo. I think you need to ask Bill Gates. What's that? We'd love to have Microsoft software in our machine. I think you've got to. We can't announce products for these guys, so I think you have to go ask Bill yourself. We did it all internally to NeXT, and we can make chips at a variety of places. We've used several people, actually. Yeah, it doesn't really matter. We did the first set of chips with Fujitsu. We could do them a variety of places. What's that? Oh, this is a very sophisticated machine, and VLSI design is not easy, nor is writing software. And so, if you drove by NeXT at 1 or 2 in the morning, over the last 9 months, you might have seen the lights burning in a few offices. But we managed to finish it, and it's come out great. And I think a few people have said it's a little late. I think most people who have seen it say it's about 5 years ahead of its time. What impact will this computer have on the computer industry? We think more in terms of what impact is this computer going to have on the people that use it. And so we are, you know much more about the industry than we do at this point. We're focusing on the people that are going to use this thing and how to bring the most far-reaching capabilities to them. And so that's where our focus is right now. What do we tell people that want to buy one but aren't in higher education? Enroll. By the way, let me take a moment to introduce a few other people that showed up. This is Rich Page. Rich is one of the founders of NeXT and has run the entire digital electronics engineering effort. Those two mainframe on a chips were the result of Rich and his group working extremely hard over a long period of time, and I'm amazed at it. Randy Hefner. Randy comes to us where he used to be at Hewlett-Packard, and Randy's been on the NeXT team for about 1.5 years now, 2 years. And Randy runs the entire automated factory at NeXT. All of manufacturing works for Randy. Susan Kelly Barnes. Susan is our CFO and is responsible for all of the finance, all of the information systems, and a sundry of other things at NeXT. Gary Moore. Gary Moore is our general counsel and also a member of the senior staff at NeXT. And George Crow. George is one of the founders of NeXT and runs all of the analog engineering and did all of the engineering for the megapixel display. All this crisp video you're seeing, we thought could never be done on a big display. And George came out of the back room one day and said, "You guys got to see this." So I think it's very easy to get up and demonstrate a product when you have such great people running the company and designing it. I am exceptionally proud of the 175 people that work at NeXT because they started without, in some cases when we started the company, of course, we just started it with a fresh sheet of paper. And as people have joined us over the months and the years, they have joined based on not a product, not even a description, they've joined on the vision. And I think this is a really great day for all of us to be able to talk about it because we haven't talked about it for so long and get some feedback. Ross?
we don't have a role. It's been a fascinating day for me. I'm one of the old people in the computer industry. Go back to the vacuum tube machines, the 650, the 704, 705. I can't tell you how many hardware announcements I've attended in my life. Now, and this is the most exciting one and the best presented one I've ever attended. I don't think Steve ever left the computer industry. You got to remember, Steve is a young man, is a very young man, changed forever the computer industry. He did things when he was in his 20s that most of us don't do until we're in their 50s. Now, while I've spent my life in advanced technology, my fascination has always been with the people and not with the chips and the machines and the lasers, because the people do all of that. I have been around many, many high-talent teams. I have been around environments to produce excellence that I thought were perfect or near perfect. The thing that captured my mind and heart and pocketbook was Steve Jobs, who at 32 has to be at least 85 in terms of business experience in the computer industry, and this incredible team that he assembled with him. And if you could be there as I have been and see them work and see the excitement and the electricity and the candor and the commitment to being the best in the world, then you wouldn't be too surprised at what happened today. Now, in closing, I got to mention this. Steve's been very sensitive. See, Susan's a Texan. And from the time I became an investor, and Susan and Bud are married. Now, you don't find that much intellectual horsepower typically in one household. So Steve and I have a clear understanding. I'm never going to try to lure Bud or Susan away from NeXT. I get first option on their children.
Thank you. We've got time for, I think, one or two more questions. Cheryl. University what? A degree? Oh, you mean the fact that I'm a dropout. Actually, I have a pretty fond spot for higher ed in my heart. What happened was I went to Reed College, just like Dr. Richard Crandall, and I ran out of money after about 6 months, so I dropped out. But they let me drop in for about a year and a half after that, and Stanford let me drop in for a year. And it's kind of something that's always stuck with me. I didn't have any money to pay, and they said, fine, just take the classes and learn. And that, to me, is what it's been all about. So hopefully, I think all of us feel really great about being able to put something like this back into that community. And again, I can't stress enough, this thing wouldn't be here today if it were not for our advisory board. They have led us into their research labs, they have let us hire their best grad students, and they have kicked us in the pants when we wanted to compromise. And more than once, matter of fact. So if it weren't for them, this machine would be a very different machine. And I think all of us at NeXT feel an incredible debt to them for hanging in there with us and making sure this thing came out great. I don't think any of us have a better crystal ball than you do. Who knows what's going to happen? We made actually a very important decision at NeXT. We said, why should a student at Reed College, a small liberal arts college with 1,000 students, or a professor or a researcher at Reed, have to pay more for their computer than someone at a very large institution, let's say the University of California at Berkeley? And the answer is they shouldn't. And so we decided, what's the best price we're going to give to anybody? And we said, can we architect our company in a way that it doesn't cost us any more to sell one computer than it does to sell 1,000? And obviously, we made some distance there, and we decided to offer our best price to everybody. So everybody gets the best price, and that's how we decided to price it. It's very democratic, and I think it's in the spirit of what we're trying to do with higher education. One last... How did we decide on the cube design? It turns out after examining several, it is by far the most efficient in terms of packaging stuff in here. As we said earlier, we've got one board in here. We have room for 3 additional boards. We can even plug 3 of our processor boards in here, in addition to the one that's in there. We can fit up to 1.3 gigabytes in here and up to 3 next year. So what you can fit in a 1-foot cube, which is smaller footprint than a PC even, is quite remarkable. Thank you very much for coming today. We really appreciate it a lot.